Most common problem that we face while handling a table data is handling null values and handling outliers, specifically when we have numerical data. In that, we'll be having values of different types. Sometimes it is integer, sometimes it is float, sometimes we'll not be having the correct value, sometimes we'll not be having values. So, outliers is actually handling a particular value that is exceeding a particular limit. In this video, we are going to clearly see what is outlier and how to handle them in a professional way. Let's get started. What is outlier? Generally, it is a part of the data. In my table, it is actually a part of the data, or it is a point that is completely different from the common observations that we have. If I have 10 different observations, I mean 10 different rows in a particular column. In that scenario, the 8 values are almost similar. If 2 values are exceeding the limit, that is called as outlier. But how to give an explanation if it is being asked in an interview? This is how. An outlier is a data point in data that significantly deviates from other observations, appearing as an unusually high or low value, potentially due from errors or rare events. How outlier got into our data? Because they entered when something wrong is going on, when they didn't concentrate while entering the data, some problem because of data entry or while copying the data, or when we do that data pipeline process, something might be missed. So because of that, we got outliers. Some column values got misplaced. Anything might be the reason. So that is how we might have got outlier into our data. So in this video, we are going to see how to find an outlier in my data and how to treat them. So for that, we need a data, right? I'm going to create a sample data. This is how I'm going to create it. First thing is I'm importing libraries, pandas and numpy. Followed by that, I'm creating a data. For that, inside a variable of data, I'm creating 3 different columns, order ID, city and sales. I'm creating that with dictionary and then I'll be converting that into data frame. For that, my column names are order ID, city and sales. Inside which I'll be having values. For order ID, I have values from 1 to 10 because I'm using range function here. When I give 1 to level, it will be giving values of 1 to 10 because the last values will be ignored because it is last value or n minus 1. So 11 minus 1 is 10 absolutely. So from 1 to 10, I'll be having my values here under order ID column name. Next to that, city. For city column, I'm manually entering the name of the city. I'm creating a dictionary. Followed by that, for sales column, what I'm doing here? For sales column name, inside that, I'm entering numerical values which could be considered as a sales value here. Next, I'm converting that and printing that as a data frame. For that, df is equal to pd.data frame of data. What I'm doing here? I'm converting this particular dictionary into a data frame. When I print df, it will be printing my first and last 5 rows. Here we totally have just 10 rows, so we got all the values. This is how this dictionary got converted into a data frame. Now this is my table with 3 columns: order ID, city and sales. What are my 10 rows? It starts with index value of 0 and with 9. Already it starts from 1 to 10. Then I have city and sales specifically entered values. The first method of finding if I have outlier or not in my data, how to do that? It is simple. In visualization, generally we'll be using 2 different libraries. Basically, we do have so many libraries, but basically we do have 2 different libraries. One is matplotlib, another library is seaborn. So in matplotlib, we have a chart called boxplot, which is specifically used for plotting and seeing if my data has an outlier. I mean, a particular value that is completely far away from my average set of values. For that, look into this coding part. First, I'm importing that library matplotlib. Matplotlib.pyplot as PLT. Next to that, for this particular column name sales, I'm creating a box plot. So for creating that box plot, this is my coding. Dot plot, when I give kind is equal to box, my pandas consider this, my matplotlib consider this as a box plot and it will create a box plot. When I give title is equal to sales distribution, see in this chart, we have sales distribution as a title. So we can do this customizations when we create chart and visualizations in Python. When I finally give plot.show, it will be printing my chart that I created. Now, observe what is happening in this chart. I do have two different dots. So what is going on actually? Come back to this data that I've created. Look into the sales column. For the sales column only, I'm plotting this box plot itself, right? So when I do have two different values that is completely far away from other set of all values, what is going on? Now, see the sales column, all the values are actually around 2000 to 3000, but these two values on my 6th order ID and 10th order ID are more than that. One value is 50,000 and the value is 1 lakh. It's absolutely an outlier. So, when I see this chart at 50,000 I have dot and 1 lakh I have dot. So, this is how through visualization I can see in my data if I have any outlier or not. If I have a large data, looking into the table and finding if it has an outlier or not, it is a tedious task. But when I create a chart like this, it becomes a piece of cake. It is going to be so easy like this. When I see dots over here, I can go back to my data and check if it has any outlier or not. If I can even use coding to find out in this range how the values are found and how to read them. So for that, I need to figure it out if it has outlier or not, right? For that, I'm using this chart. Now, I need to know the exact value. Just by looking into the chart, finding the exact number is tedious when I have so many values. So for that, finding the exact value, which value is an outlier, I'm using this. First, the method that we are going to apply here is interquartile range. What specifically is an interquartile range? Look into this here. This one. So, the total set of values, we have minimum to maximum values, right? So, in that, it is actually getting divided into four different quartiles from minimum to maximum value. In that, the middle value is a median, okay? When in between, I do have quartile 1 and quartile 3. When I have the total set of all values, in that, the 0th percentage is my minimum value and 25th percentile is my quartile 1 and 50 percentage is my median value, I mean the middle value, and 74 percentage 75 percentage is my quartile 3 and 100 percentage is my maximum value. This is how generally quartile ranges work. Now let's get into the coding part. Here for Q1, for first quartile, how to find my first quartile value, I mean the 25 percentage. In coding it is simple. I'll just call the column name sales, for which I need to find if it has an outlier or not. Next, I need to give dot quantile of 0.25. Now, my Python will understand I need to find the 25th percentile value. When I give 0.75 similarly for Q3, it will understand I need to find the 75th percentile value. After finding the values, inside an IQR, I am giving Q3 minus Q1. It specifically means find the difference between 75th percentile and 25th percentile. So IQR means interquartile range. This is what we are going to figure it out to find if we have the exact outlier value, to find the exact outlier values that we have in our data set. The next step I have to do is this formula. For lower and upper, inside the formula of lower and upper, I need to give, for lower I need to give Q1 minus 1.5 into interquartile range. For upper, it is Q3 plus 1.5 into interquartile range. Then I need to give lower comma upper. So what will it do? It will be printing my lower minimum value and average upper value and average lower value. So this is the value that is considered as lower average value. 2125 is my lower average value and 3025 is my average maximum value. After finding my uh, average low value and average high value, what I'm doing here is, for this particular sales column, if a value is lesser than lower average, or when I give this operator, it means or. If my value, sales value is greater than upper value, then print them. It means this is actually my lower average value, this is my higher average value. So in between values are common values. These are all normal values. If not, it is considered as outlier. So take them and come here and print them and give me. So look into the output, 50,000 and 1 lakh is my output with my outright and city. So this is how beautifully this coding works. It gave me the two exact values, which is an outlier. That is the power of interquartile range. After using this, the first method of handling outlier is removing it. But professionally, it is not highly advisable. But when to apply this? Why do we have this then? When my data is big, it is a big data, I could say it is like 50,000 to 1 lakh rows if my data has that. And if I just have 10 to 50 outliers or 1 to 3 outliers, removing them doesn't matter. But if I have less amount of data or if I have so many outliers, removing them will spoil the accuracy of my machine learning model that predicts my output. So to avoid that problem, what I have to do here is I need to treat that outlier. But I told you that in my big data, removing doesn't matter, right? So let's see how to remove that first. So for that, I'm creating another data frame called df clean, inside which, in another variable of df clean, inside which I'm giving the condition. If a particular value under sales is greater than or equal to lower average and it is lesser than or equal to upper average, and if data comes under these conditions, that is a normal value. If not, it is an outlier. So remove them. When I give df clean, it will be removing it and giving my output. See, here in this, we do not have the outliers. Why? Because it removed the outliers. Next method is its score method. What specifically is its score? First of all, it is actually calculating how a particular sales value, each and every sales value is far away from my average sales value, specifically when it comes to standard deviation. So try to understand this in a simple way. If I have 10 different values, in the 10 different values, one value might be the average value. Another value is a unique value. In another value is also a unique value. So when I'm trying to find the difference between my first value and an average value, that is z score. If I'm finding the difference between second value and an average value, that is z score. That is how this works. So this is used for finding a particular value is an outlier or not. Let's see how it works. So when I give this coding of first thing what I have to do is from Sky5 module, I need to import a library called stats. It will be importing my stats into my coding environment. This is a module where I have my z-score function. So after importing it, I'm creating a column of df z-score into my table. I'm creating a separate column for that, which is equal to stats.z-score, which means for sales column, find z-score for each and every values. So look into my z-score column that I have created. Observe clearly in my 6th and 10th order ID, my z-score is 1 and 1.0 and the second value is 2.6, but the other values are minus 0 point something. How this z-score works and how to use this to figure it out if it is an outlier or not. Let's see. See, if it is 0, it says my values are coming under the average values. So it doesn't matter. When I have 0.47 or something, so it is coming under that average category. When I have a value of plus 1 or minus 1, it says my standard deviation is above average. It might partially be a outlier. When my z-score value is 2.5 or 3, it says my sales is very high or very low. If it is positive, it's very high. If it is negative, it's very low. So it is having a more chance that it could be an outlier. Now go back to this table. I have 1 for my 6th order ID and have 2.67 for my 10th order ID. So my 50,000 could partially be an outlier and my 1 lakh has more chance of being an outlier. But how to confirm it is an outlier or not? If I have my values that is more than 3, it is for sure it is an outlier. So for printing any values that is having z-score more than 3, we need to use this function dot apps greater than 3. I do not have any z-score more than 3, so no values got printed. When my z-score is absolutely more than 3, it is confirmed that it is an outlier. When it is greater than 3 or less than minus 3, it is absolutely an outlier. That is how z-score method works. This is such a beautiful method for handling outliers, capping or winsorization. Most of the data professionals use this method. I told you about that minimum average and maximum average, right? When I have a value that is more than maximum average, what we'll do here is it will replace that value with maximum average. When it is less than minimum average value, it will replace that value with minimum average value. That is how this capping or winsorization works. Now let's look into the coding part. First, I'm creating a particular column called df sales cap. Then I'm giving n which is equal to np.var. So this is specifically used for finding out and fetching the data. Here I'm giving the condition. If my sales value is greater than upper, then replace. When I give first upper, it is finding if a particular value is greater than my maximum average value. After finding if it has maximum average value, my value is greater than maximum average value, what it has to do is it need to replace that value with maximum average value. If my value is greater than maximum average value, it will be replaced with that particular maximum average value. If the value is 1 lakh, it will be replaced with 3,000 and something likewise. Okay. If my value, if I am finding out a particular value that is lesser than my minimum average value, what will happen then? We will have a particular value for minimum average, right? So that value that is lesser than my minimum average value will be replaced with minimum average value. That is how this beautiful winsorization method works. So this code could be easily understood even if you look at it. See, that's how easy is this Python. Now, go to my sales capped column of 6th order ID and 10th order ID. What we have? We have 3025 for both. Why? Because this particular value of 50,000 and 1 lakh, which is upper than my maximum average value. So it got replaced with my maximum average value of the 3025. Where we found this? We have seen this somewhere, right? Where? See the 3025. We saw that at when we found my interquartile range, it is my Q3 value. It is my upper value, sorry. It is my maximum average value or it is called upper value. So we have seen how capping or winsorization works. Next, quantile based filtering. This is such a simplest method. It is not often used based on my data. If it is a finance data or web analytics or large scale data sets, specifically based on that condition and domain knowledge, you need to apply this. Based on my whole data that I do have, it will just remove my top 1%. That is how quantile based filtering works. By looking into this coding, you can clearly understand how it works. I'm creating a column. I'm creating a variable name called upper 99, inside which I'm calling my column name of sales and I'm finding the quantile of 0.99. So it will be finding all my 99% of values and putting that into that place of upper 99, this variable name. After that, if any values are lesser or equal to upper 99, put that into df of sales. Now, what is going to happen? Particular value on the top 1% will get removed. That is how this quantile based filtering works. Now, into my data, we had two outliers, right? 50,000 and 1 lakh. But in my 6th order ID, I have 50,000. When I go to my 10th order ID, the 1 lakh is not there. Why? The top 1% value got removed from my data. So that is why we do not use this often based on my requirement and need. We need to understand the domain, and based on that, you should do a research. After that, only you need to apply this method. The fifth method, it is something, it is more than statistics, it is more than concepts, it's more than functions, it's more than coding. Business knowledge. While handling any data, what you have to do is, as per my business knowledge, I need to handle it. So, sometimes, just because 10 people are purchasing under 3,000 doesn't mean one person could not purchase more than 50,000. It might be a premium order or it might be a wholesale order. So, the professional way of handling this is creating a separate column and marking this under another category. That's what we do under here. For that, I could specify the condition. If a particular sales value is greater than 30,000, create a particular column and put that under premium order category. If not, it is under normal order category. That is what I have given here under condition. Okay. So, this is something we could do professionally when handling outliers. So, we will not be missing data. Another way we could follow as a professional is flagging outliers. So when we do remove outliers or replace them, we might miss the data, right? In future, what if it is necessary? So to avoid that problem, I'm going to create a separate column and I'm going to flag and mark that particular row as an outlier and keep it. For future use, it might be used. So I'm not going to do anything. I'm not going to replace that, I'm not going to remove that, but instead, I'm not putting that under any category, sales category. Instead, I'm just going to mark it as outlier and I'm going to keep it. So if that data is required for future purpose, I can just use it. For that, look into this coding part. First, I'm creating a column called DFO outlier flag, under which when I'm using nf dot where it will be fetching and taking my data. So it's going to go and check if any sales value is lesser than lower value or greater than upper value. So this is used as R. So if it satisfies any of this condition, mark it as 1. What it means? If a value is lesser than lower average or it is greater than upper average, it is absolutely an outlier. So mark that as 1. If not, mark it as 0. So now look into this outlier flag column. I have 0 for most of the values. I have 1. Where I have 1? On my 6th order ID and my 10th order ID where I had outliers. So I'm marking it as outlier flag and creating a column so that in future I will not be missing my data. Even though it is not a need for analysis. When I need that for analysis, I could create a column like sales category. If I do not need that for analysis, but I need to keep it, then I could create a column like outlier field. This is something that you should keep in mind. Outliers are not the actual errors. They are a deviated value or something that you need to treat. Next, business logic. When handling outliers, you should be giving more importance to business logic and you should think as a profession who is working under that business, who have so much of domain knowledge in that business. It's not always about math, it's not always about statistics or Python coding. It's more about thinking with a business mindset. That is much more important in this field because it's all about money based decisions are going to be made based on what decisions you are going to give. So that is why you should think twice before giving any suggestions. The third thing, capping is better than deleting. We have seen how winsorization works, right? That's how it makes sense. Finally, flagging is safest. It's not highly advisable to delete any outliers. Keep it for future use. So while handling this, you should get a domain knowledge. You should be doing so many domain researches. After doing research only, you could handle them clearly. After handling them clearly, you will get reasons why I did this. After doing all this and finally providing the result to your stakeholder or someone, you should explain clearly with your domain knowledge. So that's what I've given here. Always explain your decision. So that task for the day. Detect outliers using IQR for another numerical column. Apply capping instead of deletion. You can take screenshot of this. Flag premium customers. Then you should find when should outliers not be treated. So create a separate IPYNB file and add assessment for this. Yeah, you should add answers for all these questions under that. So yes, I hope you enjoy the session. So if you have any doubts on this, without hesitation, you can drop them in comments. Bye for now. We'll meet you in next amazing video.